All right, so the chain rule is used whenever we have a scenario like this where we have a bracket raised to a power. Now, normally we would have something like this: y is equal to x squared, and we know that dy dx becomes multiply down by the power 2x, take 1 off the power 1. Now, there's not a huge amount of difference in what we do when we have a bracket instead of just an x here. So what I'm going to do is multiply down by the power here. So it becomes 3x plus 7, and take 1 off the power, so it becomes 2. Now, we have differentiated the bracket, and I've done that as if this was a block that I am ignoring, and I am keeping that the same and unchanged. What I need to remember then is, while I have differentiated the bracket by multiplying down by 3 and taking 1 off the power here, I have not actually addressed the fact that I need to also differentiate the x plus 7. So I need to multiply here by the differential of what is in the bracket. And if I was to differentiate x plus 7 on its own, I would get 1. So multiplying that out and tidying it up for myself, I get 3, because 3 by 1 is 3, x plus 7 squared. And more often than not, that is perfectly fine to leave your answer like that. So it's nice and straightforward. Just remember that while you have differentiated the bracket, you haven't done what's inside the bracket. So we'll go again. We'll do another one. Let's take a look at y equals, and I'm going to do x squared plus 3x all to the power of 4. Now again, what we do is we treat the bracket as this kind of block, and as if we were differentiating and that was just x. So what I do is I multiply down by the power and keep that block the same inside here, and I take 1 off the power, so it becomes 3. So let's just show you where that came from. That 4 came from down there, and that 3, let me just write it out in full so we can keep track of it. That was 4 take away 1 from the power up there. Now again, I must remember that while I've differentiated the bracket as a whole, I haven't actually addressed there's actually a function inside here that I need to look at. So I haven't differentiated that yet. So what I do is I multiply by the differential, or the first derivative of what's in the bracket here. And if I'm to differentiate that, I'm going to get 2x plus 3. So what I'll do then is I'll just tidy it up for myself. I'll have 4x squared plus 3x to the power of 3 times 2x plus 3. And what I would do then for myself to write my final answer is I would take the two easiest things to multiply and multiply those out. So I would get 8x plus 12 by x squared plus 3x all cubed. So where did I get the 8x plus 12? That came from here, the 4 times the 2x plus 3. And really, to show that we're multiplying everything by that and not just the 12 by that, I should put that in brackets to keep the meaning the same as it was before. So it's everything multiplied by the x squared plus 3x cubed. Now, if you want to know why we are doing this, I'm going to post another video on U substitution, and that will show you why we have to multiply by the differential of the bracket. So take a look at that later on. Now, one more that comes up quite frequently in the exam papers is y is equal to sine 4 of x. So y is equal to sine to the 4 of x. Now, this here, what I have, is the same thing as saying sine of x all to the power of 4. So we're back to that bracket scenario again, which we know how to handle by now. So we're going to have dy dx is equal to multiply down by the power, so I get 4 sine of x, take 1 off the power, so it becomes 4 minus 1. And again, I must remember that while I've dealt with the bracket as if it was a block, and I'm treating it as if there's nothing in there, keeping it the same, I must now remember that I have to differentiate what was inside here. And that is going to work out to be cos x using the log tables, page 25. That means sine x goes to cos x. And so what I get then is 4 times cos of x, multiplying the two easiest parts for myself, all by sine of x to the power of 3. And we can write that again, going back using this rule here. You can convert that back to be 4 cos of x times sine cubed of x, like that. All right, so it's nice and straightforward. Just take your time with them. There's nothing too complicated. And again, if you want to find out why we do this, please take a look at the U substitution video that I'll upload.